Hello and welcome. Introduction. Now, in this video, I'm going to show you how to blink the RGB LED on the Tiva C LaunchPad board. The program. So now, in this part of the video, I'm going to show you the complete program, and then later I'll walk you through the program in more detail. So here's the starting part of the program, and this might be familiar to you if you have watched my previous video, and I would recommend that you watch my previous video first before watching this video. So here I define the registers used, and here I define the section or the area of where the code is stored and its attributes. And here is the symbols for export. In this case, is __ main, and this is the entry point of the program. Now here is the main program. Again, if you have watched my previous video, this will look familiar to you. Again, the details will be coming soon. And here is one of the subroutines used. So this is the set port F subroutine. I've used this in my previous video. And then here is the second subroutine that I've used in this current program. And this is the delay subroutine. Okay, so let's take a closer look at the entire program. GPIO registers. Now here, what we're doing here is we are assigning the appropriate addresses to the registers. Now, I'm not going to go through this in detail because the details and discussion of these registers were in my previous video. Please refer to my previous videos for details of these registers. And then here, we define a section of or area where the code is stored and its attributes. Again, detailed discussion was done in my previous video. And then here we have the word export. Basically, we're saying this symbol here, __ main, is available for external use. And then finally, this entry here, this word entry here, basically designates or indicates the entry point of the program. Main program. Okay, so this is the starting point of the main program, __ main, followed by PROC, short for procedure. And the first instruction here, BL, is branched link. Basically, BL will branch to this subroutine called set port F. More on this soon. Then, followed by these instructions here. Now, I have discussed this details of these instructions in my previous video, but I will briefly talk about them here. So LDR R1, comma, equal GPIO underscore port F underscore data underscore R. Basically, this has been defined as mentioned earlier, and it has the value of 400253FC hexa. So this here has this hex value. Basically, we're loading this value into register R1. Then the next instruction, MOV R0, comma, hash hex 02. Basically, this will copy this value into R0. And then str is store instruction. Basically, this will store the contents of R0 to a location pointed to by R1. R1 is pointing to this address. So this will store the contents of R0 into that address. Next comes BL. This will branch to a subroutine called delay. Again, more on this delay soon. Notice here, oh, by the way, this 3 instructions here previously turns the red LED on. And these instructions here will turn the green LED on. If you notice, the instructions here, they are basically identical to the ones mentioned here, except that they move where instead of 02, I have 08 because I want to turn the green LED on. Let's move on to the next 3 instructions. Again, if you notice, is is identical except for the MOV instruction will have 04 because this will turn the blue LED on, followed by a call to a delay. Then here we have a branch to loop that will branch back to the beginning. So we'll repeat these instructions again. That will turn the LED on, red LED on, and then delay, then turn the green LED on, and then delay, turn the blue LED on, and then delay. And this will keep repeating itself. Now, and then here we have an ENDP signifying that this is the end of the routine. Basically, it goes with this one here. All right, END and procedure P. All right, subroutines. So in this part of the video, I'm going to discuss the 2 subroutines that are used in the main program. So the first subroutine is the initialization subroutine. Now the name of this subroutine is set port F. Now I discussed this whole subroutine before in my previous video. So if you want more details, please refer to my previous video. Now, so this is the start of the subroutine with the PROC. We are familiar with this now. So this is the beginning of the subroutine or procedure. And here, ENDP is the end of the procedure. All right, so let's take a look at these 3 instructions here. You notice that these are identical to the ones that are used in the main program. So very briefly, so this one, the LDR R1, basically this will load this value, which is this one that is being defined in the beginning of the program. So this value will be loaded into R1 or copy into R1. Then this one, MOV R0, comma, hash 20 hexa. This will copy this value into register R0. And str is stored. So store the contents of R0, which is 20 hex, into the location pointed to by R1. So R1 is pointing to this address because this was loaded into R1 earlier. So basically, these 3 instructions are identical to the ones that we have encountered earlier. In fact, it's repeated here, here, and here. We'll come to this in a few moments. So basically, the purpose of these 3 instructions is to enable the clock for port F. So that's the purpose of these 3 instructions. Now, the NOP stands for no operation or no op. Now, these 4 no op instructions, basically, the main purpose is to introduce a short delay to allow time for the clock to stabilize. Again, we see the familiar instructions here. Basically, the purpose of these 3 instructions is to prepare port F for GPIO operation. So the code here is 00 hexa. the address of this is actually here. Again, quick reminder, it's been defined at the early part of the beginning part of the program. And the next three instructions here, basically, this is to set port F for digital input-output operations. All right, so the code is here, and this value is this here, defined here again. This is defined at the beginning of the program. And then the next three instructions here, basically, this set the port F or these 3 bits here for output mode. All right, so basically this is the direction register. And then finally, we arrive this part. This is BXLR, that is branch indirect. Basically, this will branch back to the main program or return the control back to the main program. And this, as mentioned earlier, is to end the procedure. Delay subroutine. So this is the delay subroutine, and here is the beginning of the subroutine, beginning with the prog or procedure, and here ENDP signifies the end of the procedure, and we will call this the subroutine. All right, and this is the name of the procedure or the subroutine, delay. So the first instruction in this delay subroutine is the LDR register R3, comma equal 4 million decimal. So basically, the instruction will copy this value or load this value into R3, register R3. And SUBS is a subtract instruction, is new. So let's take a closer look. So SUBS is subtract immediate. So what this instruction would do is it will subtract 1 from the contents of register R3, and then the result is stored back into R3. So this is what this instruction means. So let's take a look at the example here. So assume this is R3 and these are the contents. In hexa, this would be D5, 6A, D5, 6A. So if we subtract 1 from this value, that would be D5, 6A, D5, 6, 9. And this value now is stored in R3. The previous content would be lost. So let's get back to the program. So the next instruction is BNE, that stands for branch if not equal. So what this instruction would do is it will check the contents of R3. And if it's not 0, it will branch back to this point, BNE here, which is this one here. So it will go into this loop 4 million times until the contents of R3 is 0. Once that is achieved, once R3 is 0, it comes out of this loop, come to this instruction, BXLR, that would return, this is branch, back to the calling program or the main program here. And END is the end of procedure. And this end here is the end of the whole assembly program. Now, before we go, let's take a look at this program, this subroutine again. But this time we look at the value 4 million. How did we come to this value? So the TM4C123GH6PM microcontroller has a clock frequency of 16 megahertz. Now, initially the register R3 is loaded with this value, 4 million. So the loop now iterates until the value in R3 reaches 0. So it will go around this loop 4 million times, 4 million iterations. Now, assuming each iteration takes 1 clock cycle, the total time for 4 million iterations would be 4 million cycles divided by 16 megahertz. That will give us 0.25 seconds. So the whole delay subroutine will last approximately 0.25 seconds. Hardware requirement. Now for this demonstration, you will need the Tiva C series LaunchPad board connected to your desktop or laptop. Let's remind ourselves where the RGB LED is located. And here is part of the schematic diagram, which I've taken it from the Tiva C series TM4123G LaunchPad Evaluation Board User Guide. And it can be found on page 19. And coming down here, as we can see, the red LED is connected to PF1, which is port F bit 1. The blue LED is connected to PF2, which is port F bit 2. And then finally, the green LED is connected to PF3, which is port F bit 3. Okay, so here we are with the Kyle Microvision IDE. So before I go any further, I'm going to assume that you know how to create a project and that you know how to build a file and so on. So, but if you happen to be one of those viewers that come across this video by chance and you're not familiar with the Kyle Microvision IDE, I suggest you view my other videos in this video series on ARM processor. I've included the link in the description. Okay, so back to this program here. So basically, I have declared here the registers that are used and assigned the appropriate addresses to the registers. And here I've defined where the area of code is with its attributes. And here I've exported a symbol that is _ main, meaning this is accessible by other assembly files or modules. And here entry is the entry point of the program. And okay, so here's the main program, and this is proc or procedure, which indicates the start of the main program. And here EDNP, let me just adjust this a little bit, signifies the end of that procedure or main program. So the first instruction in the main program is a branch to a subroutine called set port F, which is further down here. Alright, so we will discuss it in a few moments. And then we have this 3 instruction that will turn the red LED on. We've gone through this in detail earlier, so I'm not going to go through that. And here is the branch to the delay. Again, we have talked about this earlier. So the branch to delay is here. And then this part here, these next 3 instructions basically turn the green LED on, followed by a call to the delay. And then
these next 3 instructions here will turn the blue LED on and then call to a delay. And here is a branch, unconditional branch, back to this point here. So it turns on the red LED, turns on the green LED, turns on the blue LED, and so on. So this is an endless loop. So let's go down to the one of the subroutine here. Basically, this is the set port F subroutine. Again, the familiar proc procedure. Then here, basically, these 3 instructions will enable the clock for port F. And this next 4 instructions are the NOP, or no operation. Basically, this is to allow the clock to stabilize, a short delay here. Then this one here is set the digital enable register. Basically, that will enable the digital I/O operation of the port. Then this is the direction register is set, and then this one here basically will return the control back to the main program. And then finally, here is the delay subroutine. Again, we have discussed this earlier. So basically, that's the program. So what I'm going to do now is go to project and build the target. And I'm getting no errors and no warnings. And then here I go down to the download. Now, before I do this, this whole thing assume that you have connected your Tiva C series LaunchPad board to your laptop or desktop. I've connected mine to a laptop. Alright, here it is. So what I'm going to do is now I'm going to upload the code to the board here. So when I do that, this will just go off for a while. And the programming is done. Verify OK. Okay, so let's bring the camera back up, or the video. So I've uploaded the code here. So I need to do is to press reset, which is this button here. So let me just press reset. And you can see that the RGB LED is cycling through the 3 LEDs, green, blue, red, green, blue, red. Now, as you can see, the red, the rate of change, I think, is about 1 second. So if I go down to the code here, go down to the delay, I set it to 16 million value. Now, in our code explanation earlier, we have 4. So let's see what happens if I change this to a 4. Save it. Go to project and then rebuild targets. So no errors. And then let me download the code to the board. It's done. The programming is done. Verify OK. Bring the camera back up. Do a reset here. As you can see, the rate of change is a lot faster with 4 million. That remember the calculation for 4 million is 0.25 of seconds. I think that's about right. Okay, so that's it for this particular demonstration.
Okay, that's it for this video. Thank you for watching, and I'll see you in the next video. Bye.